Okay, 2025 additional math paper 2, question 10. The velocity v meters per second of a particle traveling in a straight line is given by v is equal to 60 minus pt squared, where p is a constant and t seconds is the time from the start. If the acceleration is 0 when t is 1, find the value of p. So to find the value of p, we've been given v is equal to 6t minus pt squared. Then we've also been told that when acceleration is 0 meters per square seconds, then time is 1 second. So you can take advantage of this and solve for p. How? You can differentiate this to get this. Remember, when you differentiate your v, you get your acceleration. So dv dt, the change in velocity over the change in time is equal to acceleration. And then when you differentiate this, you have a 6. You differentiate this, you have 2pt. And then using this information, where there is a, we can put a 0. Remember, a is the same as dv dt. And then 6 minus 2p, where we have a t, we can put a 1. And then now we can easily solve for p by taking this part to the other side. This is just 2p, so we have 2p is equal to 6. Then we can divide both sides by 2 so that p is equal to 3. And you're done with the first part. And then part b is find the time when the particle comes to instantaneous rest. So when an object comes to instantaneous rest, it means the velocity is 0. Remember, instantaneous rest has nothing to do with the acceleration. The fact that the acceleration is 0 does not necessarily imply that the velocity is 0, because when the velocity is constant, a is always 0. So when an object is instantly at rest, then we use this, v is equal to 0. Let me just write the equation with the value of p. Remember, p is 3 minus 3t squared. So to solve for t, when the object or the particle is at rest, you can just put a 0 there, because when an object is at rest, velocity is 0. In other words, the object is not moving. So now you can just factor out the t, or the 3t if you want, and then you have the 6 minus 3t, like that, so that either t is 0 or 6 minus 3t is 0. And then this one, okay, yeah, you can accept this, but because the object came to rest at one point, meaning that it was in motion first, it wasn't starting off. So that means this one can be rejected, and then you can just find the other t. Because this represents the time the object was starting off. It started off from rest, then it started moving, and then at one point it stopped. So now we want to find that time when the object came to rest. So now to solve for t, you can just take your 3t to the other side, divide both sides by 3, and then your t will be a 2. So that means t is equal to 2 seconds. And they're done with part b. Then the next part is the maximum velocity. of the particle. So we all know that at the maximum point, dv dt is always 0. So if you've been given y is equal to maybe ax squared plus bx plus c, if you want to find the maximum value of this, you can take advantage of the fact that dy dx at the maximum point is always equal to 0. The same applies to this. Your v is given by 6t minus 3t squared. So for me to find the maximum value of v, I need to find the maximum time. I mean the time at which the object is at. The particle is having a maximum velocity. So you can differentiate this. In other words, the acceleration at the maximum point is 0 because the object is not accelerating anymore. So you have this is your 6 minus, when you differentiate this, you have 6t, and then after that you can replace this with a 0 because we know that at the maximum point dv dt is always equal to 0. So you can put your 0 there, and then you have 6 minus 6t. Then to solve for t, just take this one to the other side like this, and then you equate it to 6, divide both sides by 6, and your t will be 1 second. But since we are not solving for t, we can substitute this t in the original equation. Remember, we want to find the maximum velocity of the particle, and the equation is v is equal to 6t minus 3t, and we know that the object was had its maximum velocity when t was 1 second. So you can just say the maximum velocity, you can even put the max down there, is 6, where there is t, you put a 1, minus 3, where there is t squared, you put your 1 again, so that your maximum velocity will be 6 minus 3, which is 3. Of course, we have units. This is 3 meters per second. And then lastly, we have the displacement of the particle after 4 seconds. So to find the displacement of the particle after 4 seconds, remember, to solve for displacement, you can just move backwards from velocity. So your v is given by 6t minus pt squared. So to find your displacement, you can just integrate both sides. So this side with respect to v. Anyway, you don't even need to do this side. Then this side with respect to t. So when you integrate this, you get your s, which is the displacement. And then when you integrate this, this will give you a 3t squared. Then of course our p is known, it's a 3. This one will be a 3, like 3 to the power 3 over 3, and then this will go, and then plus some constant. So now how do you get rid of this? The easiest way here is to integrate from the time it started off to the time it to the time with displacement to the particle after 4 seconds, to the 4th second. So you can just do this, or you can just find s of 4 minus s of 0. You still get the same answer. So let me just use these limits, 0 to 4. So in that case, I may not even need this because it will subtract anyway. So now when you substitute your 4, you have 3 4 squared minus 4 to the power 3 plus c, and then minus, when you substitute your 0, you have 3, 0 squared minus 0 cubed plus c, like that. And then 4 squared, this is 16, times 3, you have 48, then this would be 64 plus c, and then this is 0 minus c. So this is why we don't normally include the c when we're dealing with a bounded integral or a definite integral. So your s will be this minus this will be minus 16 meters, then this minus this, you have a 0. So now remember, this is displacement, so it can either be positive or negative. The difference between displacement and distance is that distance is just the length from one point to the other without considering the direction, but this one is a vector quantity. So the displacement AB, like from A to B, is not the same as the displacement from B to A, despite having the same magnitude.